Okay, so this is rational root theorem part 2. Here we have a first term that is not 1, so we have to list the factors of the first term and of your last term. And we're going to be dividing the last term factors by the first term. So plus or minus 4, plus or minus 2, and plus or minus 1, and then 9, 3, and 1 for this one. So for P over Q, you're going to have plus or minus 9 over 1. I'm not going to put the over 1 here. 3 over 1 and 1 over 1. And then you'll have 9 over 2, 3 over 2, and 1 over 2. I like to just go in order of the dividing, just to make it easier so you don't skip anything. 9 over 4, 3 over 4, and 1 over 4. This is a lot of factors to check without having the assistance of your calculator. So those are all the possible solutions. You're going to use two things. You're going to type this in, go to second graph, and look at your table. That will help you find one of them. Notice we have a lot of fractions here. So 3, 0 shows up in the table, which is good. That's one of the ones that we have listed out here as a 3. If you use either second trace 0 or intersect, you will get another one of negative 1/2, 0. So I'm going to use the next slide to do the synthetic division with both of those values and talk about how to factor that. You can do the work in the space that you have right underneath here. Okay, so we're going to start with 3. The factor that goes with 3 is x minus 3. Okay, so we're going to use 4, negative 20, 13, 30, and 9. I could have used a fraction first, but I figured why not get the whole number out of the way. Then you'll have less things that you'll have to divide by 2. So this will be 4, 12, negative 8, negative 24, negative 11, negative 33, and then negative 9. So you get a remainder of 0. Just like before, we're going to do synthetic division a second time with one of our other zeros, and you're only going to go up to this point. So bring the 4, we'll get negative 2, negative 10, 5, negative 6, and 3. So you do get another remainder of 0, which is good, so that also indicates that those are roots. Now normally I would have you get rid of the fraction, but we're going to make this x plus 1/2 for now, because there will be something that will multiply the fraction back in. So far, f of x equal to x minus 3 times x plus 1/2 times 4x squared minus 10x minus 6. Now we have to factor further. The last parentheses has a GCF of 2. So I'm going to pull the GCF, and actually let's put that in red, all the way out to the front. Divide each of these guys by 2. That'll give us x minus 3, x plus 1/2, and then 2x squared minus 5x minus 3. Now whatever method you would normally use to factor this last part here, you would do next. I'm going to switch the order a little bit because we're going to redistribute that 2 into the fraction parentheses. This will factor into 2x with a 3 here and a 1 here. That'll be a minus 3 and a plus 1. What you'll notice is the parentheses almost come out the same. If you were to distribute the 2 into that parentheses, you would get 2x plus 1 also. So you notice, if you go back to the graph, and this is something we'll talk about later on, you are getting what's called a double root. You have 2 parentheses that are the same, so that root gets kind of repeated. This would be how you would write your final factored form for this. Now I realize the last couple steps here are a little tricky with the distributing part. The key is just kind of getting used to the synthetic division and starting out the factoring, getting to here, and then trying to factor that a little further. If you don't quite understand the distributing of the 2, this is something that we will talk about in class together.